Assalamu alaikum. My name is Saud Hussain and I'm a student of mechatronics engineering at Air University. The project we are going to explain is our line following robot, and we have designed and implemented using MUX. And this is our overview, and we just go in through our whole circuit, how we had built it up, and using this MUX. So let's we have a breakdown structure you can see here in our screen. um, let's just start our annotation. Okay. um, so we have to build our line following robot. We can also build it by using ICs, but this was so hectic. So if one of our logic is failed, then we have to rebuild our circuit. The reason behind we are using MUX is that we can, if our one logic is failed, then we can change our terminals, so we don't have to change whole ICs. We have to just in our circuit and our connection with MUX. We use our 8x1 MUX, and using this two MUXes. One MUX control our left motor, and one MUX is controlled right motor. And these are our left sensor. These are leftmost, these are right, and this is rightmost sensor, which control our two motors, which is our this. So we have our this whole circuit. So we have how is this circuit is going to work. So let's just start our today's video. And this is our line following robot, and we have done in truth table optimization and block diagram, which is briefly described in report. I'll show you later. And hardware implementation, we first implemented our Proteus, and then our in Proteus is running, then we going through PCB, and then so forth and so on. This is Proteus and schematic, then our results. Okay, so let's first just start our logic behind our line following robot. Which logic is going through this? So in order to understand, just this is our left sensor. Let's just stop this. Okay. Just a second. Draw. Okay. This is our left sensor. Okay, this is our left sensor, and you can see center left, center right, right sensor, right motor, and left motor. When the 0 means the sensor is on white side. Okay, so our line following robot is going through black line. You can see afterwards when we play our video, and then white side is here, so no motor will be on. Okay, so when our center right, like no right and left sensor are on white, but center right or center left, you can see both inputs are on, then both motor will be on. It means the our robot will be moving forward. When just left sensor will be on, okay, when left will be on black side, then our right motor will be on. It is like that. This is our robot line, and this is our robot. Okay, so when this is going to left turn, this motor will be have 1. This have to be 1, and this have to be, sorry, this have to be 0 and this have to be 1. Okay, so when it is 1 and it is 0, right motor is on and it will go left. Okay, so it is left sensor will be 1, the right motor will be on and it will be going to right side. And when left side will be on, just you can see in this, okay, no, so 0001. Okay, this is when this is will be on, the left motor will be, right sensor on, the left motor will be on, so it will go left. So just I elaborate it with just trying like that. So um, new page is okay. So we have to build our one second. Okay, so you can see. Okay, let's move. I'll explain it later. Okay, so this is how our circuit will be moving. So it is shown here when this one is on, this left motor and left motor going to left MUX, and this is right circuit going to right MUX. Okay, so and this is motor driver module L298N, and this is our its two inputs, input 1, input 3, input 2, input 4 are this is our ground, and these are outputs. 1 and 2 is going to the left motor, and 3 and 4 is going to right motor. Okay, and these are enables which are connected to each other. Enable is 0 in this equation. Let's share our project report, which is here. Okay, so we have to make our line follower robot which can line over white background. Is just a second, we have to go through. Okay, when you can see here, when all of these are 0, then no motor will be run, and when left motor is moving, then it is going right, and when right motor all motor is moving, then all will be on, then both motor will be on. Okay, this is our PCB layout and it's a 3D view. So just we have to explain our single okay, we have used our IR sensor module, and it has 3 inputs, 3 pins. One is VCC, okay, this is our hopefully my cursor will shown to you, and this is our VCC terminal in which we have to give our circuit from 5 volt, and this is our ground, and this is our Vout. Vout is giving us to our motor driver module. If we had to move our motors, then we can give simply output to our motor driver module, which will be driving our motors. Okay, so this is our IR sensor module. You can see here, when no obstacle is around this, then it will be off. When obstacle detected, It is working through infrared sensor, optical sensor, which has source as optical sensor, and receiver as photoelectric material. So it has, when obstacle is detected, then it will give us one, and you can see it's our motor driver module. Okay, so it has four outputs: output 1, output 2, output 3, and output 4. This will be going to our motors, and these are four inputs. We just use two inputs, like we have two muxes, 8x1 and 8x1, two muxes. One is this, and second is this. Then both the input 2 and input 4 are grounds, and this is our circuit, 12 volt VCC, and this is 5 volt will be given to circuit. We have to give 12 volt to the motor driver, it will give 5 volt to our circuit, and it is a ground. Okay, so you can see here, if you can see, these are inputs, and these are this is 12 volt, this is ground, and this is 5 volt VCC, and these four are outputs. Okay, so, and here it is our mux. How it is 8 cross 1 works in such a way that it has 4 inputs and 2 outputs. Okay, so when we have to we have used we first implemented using our IC circuit. Using ICs, we have to change our logic, and in this way we have to change our ICs. So as I told you earlier, this is the major problem we faced. So we built using our MUX 74151, and these have 8 inputs and 2 outputs. Okay, so using these inputs and outputs, if our single logic is failed, then we just have to change our terminals, so we can use it as for after. So this is our state machine and state flow diagram. So IR sensor input will be going through IR sensor. The processing will be through left mux or right mux. If left mux is on, then left motor will be on, and if right mux will be on, right motor will be on. Okay, so this is a whole circuit of our just a second. This is our actuators TT gear motor. This is we bought just whole package through our vendor, and it includes our 2 motors, 2 tires, and 1 spare wheels, which will be responsible for turning, and our plastic chassis. Okay, so this is our implemented circuit robot, just now moving, and just we have to okay. So this is our whole hardware implemented. We use the workflow of our project will be this way, that we implemented on schematic, and afterwards we implemented on PCB. So we just printed out on circuit on PCB board, and after that we start etching and soldering and draining so whatsoever, and tested out on PCB, and it was working. So this is whole our implementation. We use 4 sensors, as I just show you through these. We use 4 sensors. These are sensors. Okay, and it. So this is the first one sensor, this is a 2, second sensor 3, and this is our 4th circuit, and this was our first right motor, and this is left motor. Okay, so whole our this is going through that, and circuit which is and how we use 8x1 mux is like that. Okay, just okay, these are 8 inputs, okay, and these are 8 cross 1. This is 8 cross 1, and this is also 8 cross 1, and we just use LED as we can see if our circuit is running or not. So in this way we can check our circuit, and we use connectors, cell connectors for PCB layout. Okay, and just one more thing left, I guess. Okay, so this was whole our circuit implementation, and I hopefully I explained you clearly how our circuit is working and how we built our whole implementation. Hopefully you like the video, and I have the video of our running project, so check it out and keep it. Thank you so much for watching. Keep smiling. Allah Hafiz.